being taught. Otherwise, what will happen? They will lose the interest into the topic. Like explaining this harmonic oscillator, what is the main aim in telling them oscillations? We need to tell them that the bond length of any of the chemical bond is not fixed. So it is in fact oscillating. Like a spring, like a tuning fork, like mobile phone vibrates, like guitar string. So likewise, these atoms and molecules, they also vibrates. And we need to tell them that these two bonds which are attached, they are not like a stick or they are not rigid. We need to understand when there is the closest distance between these two atoms in a molecule and when it is the largest distance. And is it possible to calculate both of them simultaneously using quantum chemistry? Yes, we have to tell them the entire IR spectroscopy, entire Raman spectroscopy, entire molecular vibrations, entire chemical bonding, even the concept of heat capacity, or for that sake of matter, the lattice vibrations, they are literally dependent on these harmonic oscillator. And we have to tell them why we are showing you these oscillations. One is kind of a pendulum you can see in the slide, and one is kind of the oscillation, the red ball. They are continuously approaching each other and moving away, approaching each other and moving away. If we cannot tell them why this phenomena is and how this phenomena is happening, we will not be able to tell chemistry student why IR spectroscopy exists. It will be impossible to tell them the concepts based on IR spectroscopy. There are many n number of examples we can tell them, like why do we study hydrogen atom first? Why we have to study the operators, wave functions, normalization, orthogonality? There are n number of things we can tell them, but then let us step into it. Let us start from quantum mechanics, classical mechanics, Hooke's law, and then starting with this classical mechanics, we can actually tell them the treatment to classical mechanics. मैं फिर से mathematics में नहीं जाऊंगा, otherwise this will be a class of mathematics. Some angular momentum if we discuss. यहाँ पर वो जो साइकिल वाला एग्जांपल दिया था, मैं यहाँ पर मैंने आई ट्राइड टू एनिमेट, गूगल से लिया हुआ है. And we can actually introduce the term of omega t plus alpha using the angular motion. This angular motion can be explained based on this, and then why there is a phase difference can be explained based on this. So again, we will not go into this detail because of the time scarcity. I just would like to come to some important points. I can come on kinetic energy and potential energy based on it, because there is a potential in the pendulum. We continuously the kinetic energy, potential energy is being converted into kinetic energy, and then kinetic energy is getting converted into potential energy. इस एंड पे आते आते काइनेटिक एनर्जी पूरा कंप्लीट पोटेंशियल एनर्जी में आ रहा है, फिर से काइनेटिक एनर्जी में कन्वर्ट हो रहा है, फिर काइनेटिक एनर्जी पोटेंशियल एनर्जी में. Likewise, the cycle will go on, and unless there is a resistance, this will go on continuously till the end of universe. There are many things. You can also tell them the atomic vibrations, how these atomic vibrations are there and how molecule forms, and when molecule forms. The quantum mechanical answers will definitely inculcate interest into the students when we deal the quantum mechanical treatment of such a harmonic oscillators, and why unharmonicity come in Moore's curve. That also you can tell at the end of this particular topic. There are many things that we can tell them. I will not go into the mathematical detail as I said, but then yes, while solving these equations, we come across some mathematical or rigorous mathematical terms which comes in the way. I am not sure how many of you or how far is the extent of students which are who are interested. Those who are physicists or those who have physical chemistry background, they are interested of it. But then yes, once we solve it, such kind of power series, we definitely do not need to memorize them. But then yes, what is the sort of power series that we need to tell them? These are the power series when we solve it, and when we come to the end, we calculate this energy of this form, n plus half h nu, or En is equal to h nu. So according to quantum theory, we come to this particular part, n plus half h nu. and NH nu for n is equal to 0, 1, 2 for based on the solution to the simple harmonic oscillator wave. And we can actually tell student when it is a case wherein my energy is ground state energy or 0 point energy, that is half h nu when n is equal to 0, or when n is equal to 1, what is the energy, and based on it I can actually classify, and I can actually tell them how this harmonic oscillator works. See, what I did is I tried to plot this equation, calculate, and then if you plot this in some mathematical instrument, you can actually take its mod. If you take, you get an orange line, and if you as such plot it, you can get this number of nodes. And this is how the quantum mechanical treatment of fundamental vibrations can be explained, और उसकी एनर्जी 0 पॉइंट से कैसे कैसे एनर्जी सप्लाई करने के बाद हायर होती जाती है, दैट यू कैन टेल द स्टूडेंट्स. Angular momentum concepts came in, wherein angular momentum has to dealt in all the direction, ladder operators, how energy is increased. Because of the scarcity of time, I will not go into it. I just would like to point out one important aspect. I'm sorry, I'm skipping this particular part, but then yes, this is the way I can explain the motion of the particular particle, and then its azimuthal quantum number part, how it has got different value for same n. We have got L, and for one particular value of L, how ml values can vary, that we can tell in animated way. Commutative property, ladder properties are involved. I'm sorry, I will skip it. Yes, this is the way you can explain for LZ direction, then for LZ minus half plus half. Rigid rotor model is that way very important, because initially, as I said, the bonds is not attached with the rigid line, but then it is attached with the flexible line. But then rigid rotor model gives you the way to calculate the energy of rigid rotor system, or even if you assume that the bonds are attached with the stick, so it will give you an opportunity to calculate energy, and then we can apply the solution. But then when we do it, there are certain interesting thing to do. See, one animation has come out here. Now the Cartesian coordinates can be explained in this way. And a particle in the three-dimensional space that is on the surface of sphere can be given like this green dot. And the blue region is actually the periphery of your sphere. Now, since atoms are spherical in nature, I cannot give the example of Cartesian geometry. And therefore, I need to explain the geometry in terms of r, theta, phi. And the biggest problem came in when we tell student how these r, theta, phi calculation came in. So the transition from the Cartesian coordinate to the spherical polar coordinate is the biggest challenge. And therefore, I tried to create one animation, and this I have designed in PowerPoint itself. And we tried to transform the Cartesian coordinate geometry into spherical coordinate geometry. See, I'll tell you. Look at this geometry. See, this is a particle which represents the Cartesian coordinates. And how to transform this x, y, z into r, theta, phi. Animated geometrical transformations are being shown here. See, instead of now cube, we have taken the example of a sphere. The angle, this is theta, which is polar angle. Now, let us plot xy plane. If I draw a perpendicular from this particular point to xy plane, I can get such a right angle triangle. This is phi, azimuthal angle in the plane. Position of my particle in three-dimensional space is r, theta, phi. Now, using some trigonometric knowledge, I can actually calculate this line z can easily be make out that it is z is equal to r cos theta, and this line is r sin theta. When I say this line is r sin theta, the line in the plane is also r sin theta. Now draw these lines across in the plane, and we can actually find out the value of x, even that is x is equal to r sin theta cos phi. So I have got now all the three lines. X is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. That way, I could get now the value for x, value for y, value for z. That means I could get all the x, y, z in terms of r, theta, and phi. Now my job becomes not simple. little bit twisting, because this is a case wherein polar coordinate can be converted into spherical coordinate, and spherical coordinate can be converted into polar coordinate. This is the animation. That is what is given. I will not show it, but then yes. So now we have got these spherical polar coordinate, and then I will take my angular momentum and ladder operator in terms of theta phi. If I remove the radial part, and I get these equations, I could generate the angular part in terms of theta and phi, and if I solve it, I get some solutions of legendary polynomials, associated legendary polynomials, and with the help of that, I get the origin of spherical harmonic. With the help of this, I could generate this wave function. See, for L is equal to 0, M is equal to 0. For L is equal to 1, there are three values of M is 0, plus 1, minus 1, and accordingly, my psi values are there. Now, can I plot these psi values? Yes, I can plot these psi values. Look at this. What I did, I fed these values to Mathematica software, and look at this. If you see, y minus 4 to plus 4 values have been fed, and see the orbital shape. One cube on the right hand side, you can see blue and red cubes are shown. These are real and imaginary parts simultaneously. Uska complementary part is given in the other part, and one is comprehensive colorful figure is shown, जहाँ पे दोनों के दोनों combined part, imaginary and real part, they are. This we have done in Mathematica software by feeding the wave function which is given above. And this is a Wolfram demonstration project available on the website of Wolfram. You can very easily show students कि जहां पर एक ऑर्बिटल रियल है तो वहीं पर दूसरा ऑर्बिटल करस्पॉन्डिंग ऑर्बिटल इमेजिनरी है. Sorry. And this way you can tell them the generation of orbitals and why the probability is real and imaginary, that way. Based on this, hydrogen atom solution is solved, radial equation is solved. See the exact conversion from Cartesian coordinate to, I'm sorry, just a minute. I'm sorry. Yeah. So the separation of variable in hydrogen hydrogen atom. Again, little bit of mathematics, not little bit, it is a much of mathematics involved into it, but then not to tell to students to this extent, but then yes, you can definitely tell students the tables which are generated out of this mathematics, and again the generation of such spherical actually generation of orbitals. Then the entire hydrogenic atom का जैसा generation है, how s orbitals are generated, how p orbitals are generated, quantum numbers का generation. You can say how this quantum number generation can be related to the concept of postal address. So principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So आपका शहर, then आपका area, आपका apartment, and exact आपका flat, exactly kind of thing you can explain it to the students. And these are the things you can explain based on all those phenomena. Although the mathematics is involved in each of these calculations, but then it is our duty, or as a physical chemistry teacher, I would say avoiding, I mean, telling the physical significance of mathematics than telling mathematics is really important. Otherwise, it is difficult to create the interest into the students for the quantum mechanical thing. I must be able to tell student मेरा क्लासिकल स्प्रिंग कैसा होगा और क्वांटम मैकेनिकल स्प्रिंग कैसा होगा. एक स्प्रिंग की मिनिमम एनर्जी कितनी हो सकती है, आप उसको दबा के दिखा सकते हैं. एक स्प्रिंग की मैक्सिमम एनर्जी कितनी हो सकती है, और एक स्टेज ऐसा भी होगा जहां पर स्प्रिंग डिफॉर्म भी हो सकता है. So as a quantum chemistry teacher, I must be able to tell them. I must be able to tell them that why only hydrogen kind of atoms are exactly solvable. Why there are other theories. ऐसी कौन सी चीजें हैं जो उनको सरप्राइज करेगी. So all in all, the quantum creating interest in quantum chemistry is that way, I guess, the job of a chemistry teacher. You can also discuss this figure in the beginning of your lecture to start in the session, and then in the end, where is the first year syllabus related, you can also discuss this particular figure with the students, that how these generations can be there. So our job is actually, we can make students to think on some ideas, like, although we cannot see electron, we trust quantum mechanics, because in every laser, in every LED, in every MRI scanner, in every semiconductor, in every chip, in every electronic part, or in every chemical bond, in every biological action, the quantum chemistry is involved. So nature is, because the quantum chemistry is probably maybe more than that. There is, I cannot claim that this is we have understood, and thereby you can create interest to the students. So these are some probability distribution curves, how atomic distribution or cloud distribution can be there, and you can explain them how the s orbital, p orbital, and their distribution can be varied based on the electron probability. I'll take this opportunity to thank the HRDC, MMTTC at Amravati University for considering me as a potential speaker to interact with all of you learned faculty members of the chemistry subject. And I hope I could make some sense through my lecture. And if any one of you, क्योंकि पिछले 1.5 घंटे से मैं ही बोल रहा हूँ, तो अगर आप में से कोई कुछ पॉइंट कहना चाहता है या कुछ पूछना चाहता है, ऑफ कोर्स सब बाकी किसी को बदरेशन ना हो, you can definitely ask me. I'm here to answer.
Thank you, sir. Participants, the forum is open for discussion, question, answer. You can directly ask the question to Dr. Vijay, sir. Please, anyone.
Sir, thank you for your wonderful presentation.
Good evening, sir.
Yes, sir. Good evening.
Sir, good evening, sir.
Good evening, sir.
Excellent presentation regarding quantum chemistry.
Yeah,
I have a doubt.
Yes.
What is the role of two-dimensional particle in a box? What is the outcome from that, sir?
Yeah, again, the concept of degeneracy starts from two-dimensional. Although in many of the textbook in classroom, we do not tell because of the short scarcity of time. So we usually tell them because the concept of degeneracy has to be introduced. And if you take them directly three-dimensional, I guess one of the aspect is this. So many a times I do not take the two-dimensional degeneracy into classroom because animations now made my job as a teacher easier.
Can you explain the unharmonicity using quantum chemistry,
sir? See, in a harmonic oscillator, we can actually say that the approach is very significant. I mean, mathematically speaking, the two atoms are approaching to each other and they are detaching. I mean, it is bonded with some kind of bond, but then when I say the anharmonicity, because of some forces, there can be the motion becomes unharmonic because of the pressures, because of the reaction conditions, because of there are n number of variables, and because of that, the motion which is harmonic, which is going on in one direction, and it otherwise will usually remain into the oscillating manner, will become deformed, and therefore, like we say that fx square, the additional term of say half x cube can be attached, which deforms the oscillation part and which makes the motion deform, and thereby after some time the harmonic oscillations comes to ceases to exist, and this is how it comes. Like two atoms, they approach to each other from a far distance and they comes closer and closer and closer and closer, and they attach at one particular point like a bond forms, and they remain into the bond state with the continuous compression and elongation. If a particular additional force is being applied to it, again the molecule try to breach the individual territory, and then energy exceeds to one particular limit, and then it explodes. The kind of phenomena can be explained.
Good afternoon, sir. Thank you for your wonderful presentation.
Good afternoon.
Sir, I have a question. Sir, if in a system we have repulsive energy, how these quantum mechanical, these postulators behave then? Like if we have some system in which there is repulsive energy, 2 electron system or so on. Sir, how these quantum mechanical equations give the result?
Yeah, see, basically superposition principle is also there, and Coulombic interaction forces also are really important. Now, see, analytically solving these kind of interactions is very difficult. There are no way in which analytically we can give answers to repulsive and attractive force simultaneously. That's what we said, that solving it for simplest of the hydrogen molecule case is a difficult system analytically. So when it comes, the number of terms involved into the hydrogen Hamiltonian will actually depend, and there are n number of softwares nowadays we can deal with it, and it can actually tell you as you go on, like basic model. If you say Hartree-Fock, we can have the interactions of wave functions in a particular manner, and that thereby you can calculate which is dominating part, and that domination actually can give you the probabilistic, I mean, weighted average of the energy, and this weighted average of energy can tell you which part is actually dominating, which part is actually not dominating. This is the way. So we have to
Hello, sir.
go the higher level of mathematics when you have to deal with the real systems. Now, the origin, if you need to tell, see, today's lecture was not to the higher level, for the higher level of quantum mechanics. These questions belongs when I first understand how the fundamental phenomena in nature happens. Why students go away from quantum chemistry is because of the mathematical terms initially introduced. मतलब हमने रिजिड रोटर मॉडल में ही हमको जब उसको लीजेंड्री पॉलिनोमियल दिखा देते हैं तो केमिस्ट्री का बच्चा डर जाता है. That's what was my intention.
Hello, sir. Good evening.
Sir, good evening.
Yeah. Sir, actually, I have one question regarding this Heisenberg uncertainty principle, as you said. Is there any physical phenomena in our daily life which we can correlate with this Heisenberg uncertainty principle so that it will be easy to explain our students?
I mean, yeah, you can relate it to the like a ceiling fan. You can tell. If you look at the
Sorry?
ceiling fan,
Ceiling fan.
हाँ, yes, a ceiling. Do you get me? A ceiling fan जो हवा दे रहा है ऊपर, अभी आपके ऊपर होगा.
हाँ, बिल्कुल.
हाँ,
Yes.
yes. So when you look at your ceiling fan and if it is moving at the speed of 4, से अगर पंखा पूरा fast move हो रहा है, can you see any of the blade? You can ask student. Can you see any of the blade of the
No, sir.
fan?
Position.
No,
It's
not
impossible.
at high
It's
speed.
impossible. Yeah, अब लेकिन वहां पे blade नहीं है क्या? Yes, all the 3 blades or 4 blades or fan are moving, but then you can clearly see the ceiling through the blades. That means you cannot track the blade right now. Now what will happen? You can actually tell what is the momentum. Now if you try to pick up one blade, see, इसका एक बेस्ट एग्जांपल बताता हूँ सर.
Yes.
एक एक्सपेरिमेंट है, बहुत सुंदर एक्सपेरिमेंट है. यू कैन टेल स्टूडेंट्स, अभी ना लेजर मशीन्स आए हुए हैं, जो लेजर मशीन्स आपका डिफरेंट फ्रीक्वेंसी पे ऑपरेट होते हैं, मार्केट में बहुत सस्ते रेट पे मिलता है. एक रूम में अंधेरा कर लीजिए और उसमें आपका फैन फुल स्पीड में रोटेट करवाइए, एंड देन यू स्टार्ट दिस लेजर, इंक्रीज द लेजर्स फ्रीक्वेंसी. A moment will come that the frequency of your laser will match the frequency or the rate of with which the fan is rotating, उसके frequency के साथ. The moment this will happen, you will see that there is only one blade to your fan. This will create the illusion to the mind of student. अब ऐसा क्यों हुआ? क्योंकि आपके लेजर की रोशनी जो देख रहा है वो उसकी फ्रीक्वेंसी और फैन के ब्लेड की घूमने की फ्रीक्वेंसी सेम है, इसलिए उसको ऐसा दिखेगा कि उसका फैन का एक ही ब्लेड एक जगह पे है. What you did, you tried to fix the position. But then can you measure its momentum now? No, it cannot be measured. It cannot be measured. So this way you can tell the Heisenberg uncertainty principle is like that only. You cannot tell that where the water molecule inside the cloud. But then yes, you can normalize the entire area and you can tell, yes, this is the probability with which water cloud or water molecules can be there. This is what these are what example. Heisenberg uncertainty principle is very relatable and very relative.
Yes, that is why I'm asking, and always when we discuss with the students.
So I guess ceiling fan
initially-
example is best suiting classroom में बच्चों को बताया जा सकता है.
Okay, thank you, sir.
Thank you, sir.
Hello, sir. Good evening, sir.
Good evening, sir.
Sir, I have two queries. I am from inorganic chemistry background. I don't know is it suitable to ask you the question,
Not
but
an issue,
still
sir.
I
We will
am
discuss.
asking. Is it there is any experimental evidence for finding 0 point energy, and also it is energy measured directly?
Yeah, with the advent of the technology, I am not really sure that, but then there are certain mathematically derivable experiments from which we can see
Yes.
for a particular state of a system or energy state, it has been calculated much earlier than any experimentation. But then, yes, there are some bosonic condensate kind of experiments wherein we can actually calculate the ground state energy, I guess. But I am not very sure, sir. We will have to see actually. But then I guess the condensate experiments can tell you the fundamental 0 point energies.
Okay, sir. Thank you, sir. Nice presentations.
Hello, sir. Sir.
Hello, sir. Yes.
Hello, sir.
Hi, sir.
Sir, you nice explain the quantum chemistry on the presentation. Sir, I have to ask a question, sir. Sir, irreversible thermodynamics. Sir, you are from the irreversible thermodynamics, but sir, there is a very few books on the irreversible thermodynamics. Students get the difficulty for the irreversible thermodynamics. So, sir, can you suggest any book which are very easy for the student, master degree students?
Yeah, there are two fundamental books which I guess every student should refer to while studying the irreversible thermodynamics. That is, one is by Prigogine and Glansdorf.
Sir, Prigogine.
Prigogine and Glansdorf.
And sir?
Glansdorf, Glansdroff. Glansdorf.
Okay, sir. Glansdorf.
Irreversible processes, the thermodynamics of irreversible processes, the textbook.
Okay,
and the second book is by Ilya Prigogine itself. He is the sole author.
Okay, sir.
And one more textbook by Professor R.P. Rastogi, our very own BHU Vice Chancellor.
I am sir follow that book, sir.
Yeah. So there are two books. One is for the thermodynamics, advanced thermodynamics is one book, and the other specialized book by Professor R.P. Rastogi is for irreversible processes, thermodynamics of irreversible processes. So did you see that? I mean, I don't know. That book.
Okay, sir. Yes, sir. Sir, I am following the introduction of chemical thermodynamics.
That is a fundamental book that only deals with the reversible thermodynamics.
Yes, sir. Very short notes on there, sir.
Yeah, for irreversible thermodynamics, I guess a book of irreversible thermodynamics, processes of irreversible thermodynamics. I don't exactly remember, but then the book is by Professor R.P. Rastogi and it is published by Springer.
Springer, sir.
Yes.
Okay, sir.
So this book is really important.
Yes, sir. Really, sir. Yes, sir.
One more book is Modern Thermodynamics by Dr. Kondipudi.
Sir, Professor?
Dr. Kondipudi, Dilip Kondipudi.
Okay, sir.
These are some books which describes thermodynamics in a lucid manner.
Yes, sir. Sir, really, sir, very hard book is there, sir. There is no more book, sir, for the thermodynamics. So,
yes, sir, you can take my number. I mean, we can discuss. My email ID is given on screen.
Yes, sir.
You can take this and we can discuss this topic. Ganesh,
Okay,
sir, good evening.
Hello, sir.
Thank you, sir.
Yeah, I'm Ganesh.
Very nice to see you after a long time.
Yes, sir. So we met long back in Pune.
Yeah, sir. Yes, sir. Very happy to see you.
Yeah, actually, I'm from inorganic. And now I'm thinking that I would have sit in your regular class in quantum chemistry so that you would have learned it better. I want to share one thing, sir. I'm not asking any question. These days, I was reading a book, The Secret of Scent by Luca Turin.
Okay.
This is about the science of smell.
So great.
This book finally goes to the vibrational theory of olfaction, and that goes to the inelastic electron tunneling.
Okay.
Yeah, one thing. And later I went to another book, The Biology of Belief by Bruce H. Lipton.
That's
so
great, sir.
It's also a book that goes to the biology, finally goes with the quantum chemistry only.
Oh.
This book referred to another one, The Cosmic Code.
My God.
This is by H.R. Pagels.
There could have been specialized lecture for this.
Hi, is it, sir? Okay. So this is about quantum physics as the language of nature. And finally, I reached to another book called The Answer for the Everything Answer book by Amit Goswami.
That's
So
great.
actually this book is regarding quantum. It goes with our daily all these things. And finally, now what I see is many Nobel Prize are coming to quantum dots, and this year also quantum entanglement and all. So many research is getting into the quantum field, these things, and also the quantum computers and all. So what would you say finally about this in general quantum understanding?
Yes. So I'm just saying
It was an excellent presentation, sir. You meant the examples that you took, so that really make us interested and to also follow the core concept. Thank you very much.
These animations I created for this Vayu channel.
Very nice, sir.
Yeah. Thank you, sir. Thank you. Thanks a lot. So, friends, thank you very much for giving me this opportunity.
Thank you, sir. Thank you so much.
Yeah.
If
Shall I
there
take
are
your
no
leave now?
questions, then we can conclude, sir, if you could permit.
Yeah. Thank you.
Yeah. So now, lastly, may I request vote of thanks for the current session.
जी सर
Yeah.
May I audible?
Yeah, Dr. Nutan, sir, please.
जी सर myself नूतन कुमार दीवान असिस्टेंट प्रोफेसर कॉलेज धमतरी छत्तीसगढ़ आज क्वांटम केमिस्ट्री विषय पर आयोजित इस ज्ञानवर्धक सत्र के लिए आभार प्रदर्शन करने का अवसर पाकर मैं स्वयं को गौरवान्वित व सौभाग्यशाली महसूस कर रहा हूं। एक प्रसिद्ध कहावत है, ज्ञान बांटने से बढ़ता है। आज का यह सत्र इस बात का उत्कृष्ट उदाहरण रहा है। सभी प्रतिभागियों की ओर से मैं हमारे सम्मानीय रिसोर्स पर्सन डॉक्टर विजय टांगड़े सर का हृदय से आभार व्यक्त करता हूं। सर, आपने क्वांटम केमिस्ट्री जैसे जटिल विषय को अत्यंत सरल, सहज, प्रभावशाली ढंग से समझाया। आपके व्याख्यान ने इस विषय को समझने के लिए हमें बहुत आसान बना दिया है। सर, आपका बहुमूल्य ज्ञान, अनुभव और अमूल्य समय हमारे साथ साझा करने के लिए आपका हृदय से धन्यवाद। मैं साथ ही इस कोर्स के कोऑर्डिनेटर डॉक्टर मनीषा कोडाबे मैडम का भी हृदय से धन्यवाद करता हूं। साथ ही हमारे टेक्निकल एक्सपर्ट श्री अंकित ठाकुर सर का भी मैं हृदय से धन्यवाद ज्ञापित करता हूं। अंत में सभी प्रतिभागियों का भी हृदय से धन्यवाद ज्ञापित करता हूं कि जिनकी सक्रिय सहभागिता और उत्साहपूर्ण उपस्थिति और सार्थक संवाद ने इस सत्र को और अधिक सफल और यादगार बनाया। आप सभी का बहुत बहुत धन्यवाद। आपका दिन शुभ मंगलमय हो। थैंक यू सो मच।
Thank you, sir. And thank you, Professor Vijay, sir. With the kind consent of Professor Vijay, sir, I would like to declare that today's sessions are over here and we will stop now and meet tomorrow. Thank you, everyone.
Thank you, all of you.
Thank you.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank you.